Okay, let's look at the whole assembly before we start the demo. This is our motor assembly. Motor's in this box here. Rotating platform, and this housing holds the LDRs. This LDR is pointing towards the light source, which is going to be the window here. And when it's over in this direction, it's going to be in shade. Now, we have reed switches here and here that are going to change the direction of rotation, as we'll show in the demo. We have a 12 volt power source going in here because the motor runs off 12 volts. But we have a voltage regulator here to bring us down to 5 volts for our electronic circuitry here. The relay, the 2-coil latching relay, is a 5 volt relay, but it needs a little bit more than 5 volts just to kick it. So we're going to run the 5 volt relay through a 9 volt battery to click on and off the coils. Now this behaves poorly and I need to keep it pushed down in order for the contacts to connect and reverse direction. So when it starts operating, what we want to see happen is we have the LDR here, the shade detecting LDR is pointing towards shade. That will detect shade and the circuit will turn on the motor, and the motor should rotate around towards the light source and stop. Now we have a reed switch here and a magnet there. And when the whole assembly rotates completely 180 degrees, it's going to engage this reed switch here, which will switch the relay and reverse rotation of the motor, and the assembly will return to east. So we go from east to west, end of the day, it stops and rotates back to east for the start of a new day. This LDR here will tell us whether it's in daylight, so it doesn't operate when it's dark, because we don't want the thing moving around all day when it's dark. Okay, so we're going to demonstrate the assembly. Currently the LDR is pointing in this direction, which is shade, and this direction here is towards the window, which is sun. If we turn on the power, we should rotate towards the sun. And stop. Now we can see if I just rotate the assembly away from the sun, it's going to come back and track it. So you can see that. Now if I cover the LDR so it's in shade all the time, we'll see it repeat a full cycle. So it's going to track the sun over the day until it gets to west, and then it's going to return back to east. Now it's the end of the day and we have darkness, so it'll just track back to east. But we have our daylight sensor covered because it's dark, so it'll track back to east and stay there until the next day. So we're going to look at the board in a bit more detail. We have a 12 volt power source here because the motor runs off 12 volts. 5 volts voltage regulator here, and here's our various electronics relay here. So this LDR is going to detect shade / dark, and we'll have it mounted in the assembly. Going through two transistors here. Then we have the daylight detecting LDR here that tells me whether it's daylight or not. That's going through a transistor. And then we're connecting the motor through the various connections of the relay. Now the relay coils are activated through a 9 volt source here. So we have a 9 volt source running the relay coils to activate them on and off. And they're switched on and off with reed switches that are going to be mounted on the assembly. Here's the circuit diagram. We have our 12 volt power source, and here's the 5 volt regulator. This is the shade detecting LDR circuit. It works as a voltage divider. So when in shade, it will allow current to flow through the motor and so turn it on. This is the daylight detecting LDR circuit, and as you can see, it's on the ground side of the shade LDR circuit. Thus, if it is not daylight, current cannot pass and so the motor will not switch on. A separate video is on this channel explaining the operation of a voltage divider. Also on this channel there are videos explaining the operation of relays and latching relays. You may notice that I have two transistors in series for the shade detecting LDR circuit. This is known as a Darlington pair and is necessary to allow sufficient current to flow through the second transistor to turn on the motor. Here is the motor relay part of the circuit. I am using a 2-coil latching relay to switch the direction of rotation of the motor. Here in the diagram showing two separate relays, as Fritzing doesn't appear to have a 2-coil relay in the library. The contacts on the relay are as follows. Top one here is called normally closed, the middle one is called common, and the bottom one normally open. The relays are configured as common, normally closed for rotation of the motor east to west, so the flow of current through the motor follows this path, and so to ground. As you can see, the plus side of motor is connected to plus side of the circuit, and the minus side of motor is connected to minus or ground of the circuit. When the motor completes a full 180-degree rotation from east to west, the magnet will activate this reed switch S2, which will change the relay configuration to common, normally open, and so the current through the motor follows this path. Now, the minus side of motor is connected to the plus side of circuit, and the plus side of motor is connected to the ground of the circuit, and the motor rotates back from west to east. When it returns to east, the magnet would activate reed switch S1, which returns the relay configuration to common, normally closed. Because this is the end of the cycle, at day's end, there should be no sunlight, and so the motor circuit will have no current passing through it until the next morning.